Hello everyone. In this question it is asked that we are to prove that tan of 7.5 degrees is equal to square root 6 minus square root 3 plus square root 2 minus 2. Okay, so the RHS is very convoluted at first glance. Okay, also 7.5 degrees, like 7.5 degrees is not a very standard angle at all. It is like half of 15 degrees, right? And 15 degrees also not standard. So how to start? Okay, so let me start by writing the standard multiple angle formula of, let's say, we have 1 minus, we have cos 2 theta equal to 1 minus 2 sine squared theta. Okay, then we have, from this equation we have 2 sine squared theta equal to 1 minus cos of 2 theta. Okay, let us write this equation 1, and we also have sine of twice theta equal to 2 times sine theta cos theta. Okay, so let me just rewrite it. This side, this 2 sine theta cos theta in the left hand side. Okay, so by rewriting we get 2 sine theta cos theta equal to sine twice theta. Okay, so our target is to find tan of this, right? So let us first try to find out a value of tan theta in terms of some half angle identity. Okay, let's see if we can find something out. So first I will try to divide this equation 1 upon equation 2. Okay, to see, let's see what we get. 1 by 2 implies that 2 sine square theta upon, this is 2 sine theta cos theta. Okay, so this implies 1 minus cos 2 theta upon sine 2 theta. So in the left hand side we see 2 will get cancelled out, sine theta and sine square theta. 1 sine theta will remain in the numerator and 1 cos theta will remain in the denominator. So from this we get an expression for tan theta in terms of multiple angle. Okay, so we get tan theta equal to 1 minus cos 2 theta upon sine 2 theta. Okay, so this is the equation or expression for tan theta in terms of twice theta. Okay, in terms of sine twice theta, in terms of cos twice theta. Okay, so here if we replacing theta by 2, we get the new expression. Tan theta will be replaced by tan theta upon 2. Okay, tan theta upon 2. So if theta is replaced by theta upon 2, twice theta, if we double this will become 2 times theta by 2, which becomes theta, right? So here we get 1 minus cos of, this theta will be replaced by theta by 2. Okay, so 2 times theta by 2 will become theta. So this becomes 1 minus cos theta upon sine 2 theta will be sine theta. Okay, so this is an expression for tan of half angle in terms of, like, standard angle, or let's say multiple angle. Okay, so this expression or equation will be used while evaluating this value of tan 7.5 degrees. Okay, so let us now start. We have tan 7.5 degrees is tan of, if you are to make 7.5 degree as half angle, we can write it as 15 degrees by 2, right? 15 by 2 is 7.5 degree. Okay, so now we can use this equation, this above equation, and we can write it as this tan 15 degree by 2 will become 1 minus cos of 15 degrees upon sine of 15 degrees. Okay, so again, this 15 degree, cos 15 and sine 15, these are not standard angles, right? Okay, so we have to further evaluate those values in order to get tan 7.5 degree. Okay, So tan of 7.5 degrees will be 1 minus cos of 15 degrees can be written as 45 degree minus 30 degree. Okay, and this similarly in the denominator, sine 15 degree will be sine of 45 degree minus 30 degree. Okay, so now this is cos of a minus b and this is sine of a minus b. So I can use the standard formula cos a cos b plus sine a sine b in the numerator, and the denominator it will be sine a cos b minus cos a sine b, and sine 45 and sine 30, cos 45 and cos 30, these are standard known values, right? So we can use those values here. So in the numerator we have cos 45, let's give a bracket here, cos 30, and cos a minus b have cos a cos b plus sin a sin b. Divided by sin a minus b is sin a cos b minus cos a sin b. Okay, so on further evaluating this, we get 1 minus cos 45 is 1 by root 2. Okay, so I can write 1 by root 2 as root 2 upon 2. Okay, I can write it like this, root 2 upon 2. If we cancel by root 2, we are left with 1 in the numerator and root 2 in the denominator. Okay, so I just multiplied 1 by root 2 with root 2 in both numerator and this denominator to get this root 2 upon 2. Okay, and cos 30 is root 3 upon 2, and again sin 45 I will write it as root 2 upon 2, and sin 30 is half. Okay, so numerator is done. Denominator we have again sin 45 is root 2 upon 2 times cos 30 is root 3 upon 2 minus cos 45 is root 2 upon 2 times sin 30 is half. Okay, so in the numerator we now have the denominator will be same, denominator will be 4 here. You can multiply, take the product of the numerators. The root 2 times root 3 will be root 6 plus root 2 times 1 is root 2 divided by 4 upon root 2 times root 3, this will be root 6 minus this is root 2 times 1 is root 2 upon 4, right? So we have this expression. Okay, so it is simplifying. Okay, let's see what happens further. We have tan 7.5 degrees. If we take the LCM in both numerator and denominator, we are left with 4 minus root 6 minus root 2. This is divided upon 4, and in the denominator of this fraction we have root 6 minus root 2. This is again divided by 4. Okay, so we can cancel off these 4s, so we are left with 4 minus root 6 minus root 2 upon root 6 minus root 2. Okay, so far so good. Okay, so now I will try to rationalize this denominator root 6 minus root 2. Okay, so in order to rationalize I will multiply by the conjugate. So I'm multiplying both the denominator and numerator with root 6 plus root 2. Okay, so now we get tan of 7.5 degrees. We have to multiply the numerators here. So 4 times root 6 plus root 2 will give 4 root 6 plus 4 root 2. Then root 6 times root 6 will give us 6. Then root 6 times root 2 will give us root 12, which is minus 2 root 3. Okay, then we have minus root 2 times root 6, which is again minus 2 root 3. Then minus root 2 times root 2 will be minus 2. Okay, and in the denominator we have root 6 minus root 2 times root 6 plus root 2. So this is a minus b times a plus b, which is formula for a square minus b square. Okay, so a square will be root 6 whole square minus root 2 whole square. So okay, let us write it down once. Root 6 square minus root 2 square. Okay, so now we are left with root 6. There is only single root 6. It is 4 root 6 plus there is a single root 2. So this is 4 root 2. How many root 3's are there? There are negative 2 root 3 minus negative 2 root 3. So this is 4 root 3, and then minus 6 minus 2 is minus 8. Okay, and root 6 square is 6 and root 2 square is 2. So this becomes 6 minus 2, which becomes 4. Okay, so it seems like we have finally completed. It seems we are very close. So if we take 4 common in the numerator, we get root 6 plus root 2 minus root 3 minus 2, right? 4 root 6 plus 4 root 2 minus 4 root 3 minus 4 times 2 is minus 8. Okay, so we have taken 4 common from the numerator. Okay, and we have a 4 in the denominator, so we can cancel this. So finally we are left with root 6. What we have to show? Root 6 minus root 3. Okay, so let us write root 6, then minus root 3, then plus root 2, then minus 2. Okay, so we have completed it. We have proved the sum. Okay, so this was a bit convoluted and a bit lengthy. Some calculations were required. I deduced the formula. This for if the formula is already known to you, you can directly start from here. But in case you don't know the formula, you can try to derive the formula like this. Okay, and we have just computed after using this deriving this formula. I've used this formula, and then I've just computed these values of cos 15 using the compound angle formula. Okay, this cos 15 and sin 15, and the rest is just calculations and computations. Okay, so this is it. Okay, thank you.